I'm Mark. I don't have any social media accounts or anything, so follow me here. Hire a private investigator if you want to follow me, I guess. I'm a Haskell developer. That's what I tell myself. Whether that's true or not is for others to decide. I'd also like to apologise in advance. I've basically not slept for about a week, so apologies in advance if nothing I say makes sense. That's just an excuse. Adam said I'm allowed to do some shameless self-promotion. So shameless self-promotion. So I work for a company called Develop Me. About half of the people here have already done our course, so speaking to the converted. If you want to learn web development, you're probably already doing it, but if you want to learn even more, do look us up. Also, we're interested in looking at people who could potentially teach for us at the moment. The syllabus is JavaScript and Laravel, mostly PHP, mostly using Laravel. So if that's stuff that sort of you've got expertise in and you might like to teach on the course at some point, do just drop me a line at mark@developme.tech. We might not have places like immediately, but like if you're interested just at any point in the future, do get in touch. That would be great. So this is how I can call myself a Haskell developer. I've built a little command line app called taskell, and it's basically Trello, but on the command line. So if you love your Vim key bindings and you live in the terminal, which is where I spend most of my time, now you can have Trello without having to go to some awful website. I love Trello. It's one of my favorite websites. But command line. That's what I waste my time doing. A long time ago, I did a talk at Bristol.js. It was roughly 3 years ago. And a month or two later, I joined the Bristol.js Slack channel. I think it was fairly new at the time. And Adam sent me a message saying, did I want to give a talk? So, Adam, I literally just gave a talk like last month. So I said one talk every 3 years is quite enough. Book me in for December 2019, which he did. So this event has been on Meetup for 3 years. We've been having to update the title of it over the years because on Meetup it just says November. And so people have been signing up for this event since we basically put it up. Has anyone been signed up for it since 2016? Hopefully not. Oh, a couple of people. Thanks. I admire your commitment. I'm kind of only doing this talk as a running joke. So apologies if it's not very good. So in those 3 years, I got a cat. I have a son now. He didn't exist 3 years ago. I became the second highest trending Haskell developer in the world. To do that, just write a Haskell project that gets 20 stars in a day. The secret to getting high up here is to use a programming language that no one else uses. Except for Facebook, apparently. But who's heard of them? I've been teaching for Develop Me for 3.5 years now, but I actually 6 months ago got a job with them, so I'm now the curriculum director as well. This is our 6th cohort. Aren't they all happy? Unfortunately, I also wrote this talk 3 years ago, so hopefully it's still relevant. 3 years ago, I gave a talk about functional programming. I'm going to be talking about function composition. I decided to talk about this about a year ago, I guess, and it was having taught a lot of people how to program JavaScript. And I realized that this is something that actually comes up again and again and again the curriculum in sort of different ways. Sometimes they're called different things, but sort of the underlying idea just keeps on coming up. So I think the first thing to say is you already know a lot of the stuff I'm going to tell you. I don't think I'm going to be telling you the stuff near the end, maybe if we get onto that where it gets a bit technical. Maybe that stuff's new. A lot of this stuff that I'm going to tell you, I suspect you probably already sort of know deep down in your heart of hearts. So it's kind of more just sort of encouraging you to live that life. Embrace function composition like you know you really should. On the course, I teach these 5 weeks of the course. It's a 12-week course, and I teach these 5. This just seems like a big, long thing to develop me. This does tie in. So I teach the fundamentals of programming, so that's when people first sort of learn, and we use JavaScript to teach that. I teach the DOM. I teach object-oriented programming with PHP, and then we do React and Redux at the end of the course. And as I say, it was teaching these weeks of the course that I realized that this thing comes up again and again. So with fundamentals of programming, functions, we learn about functions and we use functions all the time. If you want to do a bit of code again and again, then that's what a function is for. And I think most of you probably are aware of that. We'll pretend that I don't teach the DOM. It doesn't really come up in the DOM. Object-oriented programming. So the solid principles, if anyone's done a lot of object-oriented programming, then those are things you're probably aware of. Single responsibility, stuff like that. Again, sort of function composition, the ideas of function composition come up a lot in object-oriented programming. In React, we use components. And again, function composition and components, really key ideas. And with Redux, we have reducers. And again, it's all about function composition, really. So what do I mean when I'm talking about function composition? So at the moment, I'm talking about it in sort of not technical terms. I'm using the term really quite loosely. If there is time at the end, I will briefly talk about sort of technically what function composition means. There is a sort of, there's the Haskell function composition stuff. But for now, I'm just using it fairly loosely. And all I really mean is write little short functions that do one thing well and then just use them in your app. That's all I'm saying. And as I say, you already know to do that. But the simple fact is, I bet a lot of you probably don't do that. I certainly don't do that all the time. I write these big, messy functions, and I'll often refactor them into nicer ones eventually. But the simple fact is, often we do just write big, behemoth functions that aren't actually very nice. So why is it a good idea to write small, reusable functions? So the thing that all of those have in common is they're effectively black boxes. So I'm sure you've all heard the term black box before, but the idea is that we know what the inputs are and we know what we expect the output to be, but fundamentally we don't need to know actually how it does that. If we have a number, a function, for example, that we pass it a number and it tells us if that number is prime or not, we don't actually need to know how the function does that. We just need to know that the function works. Like, we can assume that the function works, that it's been tested and all that sort of stuff. As long as we know that the functions work, we can just give it an input, and as long as we know what the output's meant to be, we'll get back the sort of output. So as long as it's well documented, black boxes are a great way of working. And as I say, these come up again and again and again. So when we're using functions, ideally we want functions that when we pass them some values, the things that we'll get back are predictable results, that they don't go and break things. When we do object-oriented programming, we want our objects that we use to be predictable. We want them to accept certain methods and give us back certain sorts of results, and not to just unexpectedly do other weird stuff when we haven't asked them to. Components in React, the whole purpose of components in React is we can create these little reusable bits of Vue UI that we can then put anywhere in our app, and they're just reusable. And the smaller those are, the more reusable they become. And in Redux, we have reducers, little bits of code that update the state. And again, the smaller those are, the more reusable they become. So this concept of black boxes is really important. So there's this thing called Gall's law, proposed by a chap called someone or other Gall, Mr. Gall. Actually, I think he was a doctor. He was a paediatrician. And he studied systems. And this quote comes from him. He says, "A complex system that works is invariably found to have evolved from a simple system that worked. A complex system designed from scratch never works and cannot be patched up to make it work. You have to start over with a working, simple system." So this is sort of the key idea that I want to get at. If we build our programs of small little things that we know work well, we can actually get a surprising amount of complexity from them when we know that each individual part works perfectly well. So the idea is that we can get complexity from simplicity. And that's the only way that you should get complex apps, by building up lots of simple things to create complex behaviors. So it's kind of black box inception in a way. And I found this nice little GIF that doesn't really illustrate anything, but I figured I should get there's a GIF. And as I say, you already know this. Unix pipes, I'm sure most people have probably used pipes in Unix, maybe not fully knowing what they do, but the sort of Unix philosophy is you write small little bits of code that just do a single thing, and then you can use pipes to get the output of one to go into the output of the next one. So this is one that I use all the time. So when I'm teaching, I have a little scripts folder even, where all my little notes that I'm working from for each day are in little markdown files. And at the beginning of the week, I just need to print all of those out so I've got something to work from. And so I just do cat scripts md, and that's just going to find all of the markdown files. And then I pipe that into pb copy, which just adds it to the clipboard on the Mac. And then I can just paste that into an app, and I've suddenly got all of them in a single file. This is a slightly more involved one. So we list all the files. We then use grep to find all of the ones that have org, so if they have August in the date. Then we sort by the date column, and then we output that using less so that we can see lots of lines of code without it all running off the screen. So again, this is function composition. We're listing some files. We then take the output of that and pass it to grep. We then output that to sort, and then that to less. We're just combining simple things to get much more complex behaviors. So I've already sort of covered this to some extent. Why do we want to do this? So, I mean, the first reason is that brains are limited. There's that famous sort of pop psychology thing that brains can remember 7 plus or minus 2 chunks of data, whatever a chunk is. I don't know if that's been disproved. Most psychology has nowadays. But, you know, the general idea is your memory is not very good. I had someone on the last course put their hand up as I was sort of explaining some quite in-depth DOM thing, and he was like, "Do we have to remember everything about this?" And I was like, "Good Lord, no." Like, I mean, as a developer, I can't remember most of the code that I wrote, let alone other people. Like, that's why we have documentation, and that's why black boxes are so important, because we don't need to know how the things work. We just need to know what they do. And it's because our brains are limited. Like, we shouldn't need to remember how everything works. And function composition can help us a lot to get around this problem. The other thing is, if you've got small little functions that do one thing well, you'll never need to change those bits of code. So Sandy Metz, people heard of Sandy Metz? Show of hands, Sandy Metz? That's okay. If you haven't heard of Sandy Metz, and you're doing any sort of object-oriented programming, or just programming generally, you should look her up. She is life-changing. I honestly changed how I program after I read her book, which all the Ruby people call Poodle. I call it Poo Doctor because it's funny. Which is Practical Object-Oriented Design in Ruby. So it's about Ruby, but it's really about object-oriented programming and how to do it well. And she talks about sort of, we often talk about code being elegant, and Sandy Metz says that elegant code is code that can be changed easily. Because actually, most of your time as a developer, you're changing code. And so if you're using function composition properly, you're going to have lots of bits of code that you will never need to change again. You can just use them again and again and again, and that makes changing other bits of your code much easier. So function composition can really help with changeability. I say, if you've not heard of Sandy Metz, do look her up on YouTube and watch every single video that she's ever done, because she's been doing it since she was like working with Smalltalk, the very original object-oriented programming language, and has been doing object-oriented programming basically as long as it's possible to do it. So she really knows what she's talking about. So another thing, it makes unit testing really easy. If your code's made up of lots of small units, you can test those units really easily without having to rely on more complicated things to do with the environment or what the program's actually trying to do. You can just test individual functions, see that they do the thing they're meant to do, and then you don't need to worry about it again. You know, if you've got a function that works for telling if a prime number is a prime number, you never need to change that again. It just works. And unit testing that is relatively easy as well. So those are three reasons to think about it. So it's all about reuse. And again, this is stuff, everyone knows this. This is stuff everyone knows. We should write short functions, we should reuse them, and that's how we're going to build stuff. So I'm going to give a couple of examples that have come up through the teaching stuff I've done as well, because it turns out my students are much better at this than I am. So this is a max function in JavaScript, so we pass it two numbers, and it just gives us back which of those numbers is bigger. And a lot of people probably wouldn't bother writing a max function because it doesn't seem terribly useful. You could probably just write the ternary expression wherever you needed it, and you probably don't need the max function at all. So it kind of seems a tad on the pointless side. It's the same with an add function, a function that takes two numbers and just adds those two numbers together. You'd just use the plus operator. But it turns out this seemingly quite pointless function is actually very useful. So one of the questions that the students get in sort of the day when they're learning about functions is write a function that takes three numbers as arguments, so A, B, and C, and just return which of those numbers is the biggest number. So if we pass in 1, 2, and 3, we'll get 3 back. 5 minus 5, 0, we'll get 5 back, etc. And my sort of, the answer that I always gave them was this. And I think this is probably what most people would write, something like this. You take the three values, you say if A is bigger than B and it's bigger than C, then it's A. If B is bigger than A and it's bigger than C, then you can return B. If it's not either of those, then we can just return C. Don't need an else statement, save ourselves a few lines of code. And that is the example answer that I had in the notes for a number of years. Then one of the other instructors on the course, Ollie, pointed out that actually we can simplify it a bit. We don't need the two checks on this line here. We can just, if we've got to this point, then A can't be the biggest, so we don't need to check if B is bigger than A, because A can't be the biggest anyway. So we can simplify it slightly. And I thought that's a nice thing. We've made this code much better. And then a couple of cohorts ago, someone called Tom, who'd literally been programming for 2 days at that point, I asked, has anyone done it? I always get them to put their code up, and I always say, has anyone done it differently? And he put his hand up, and I was like, oh, okay, what have you done then? And he puts that up. And I'm like, that's so much simpler than what I've done. I mentioned function composition, and he took it seriously. He spent the time, and he noticed that if you already have a function called max that you can pass two numbers and get back the biggest number, then you can write one called max free, where you just first get the biggest number of A and B, and that's either going to return A or B, depending on which one is bigger, and then just do max of whatever you get back from that and C. And you get exactly the same thing, but the code is so much tidier. And this is function composition. A previously fairly pointless looking function actually becomes very useful. I know that this is a really simple example. You might think this isn't the sort of thing you have to do all that often. But I need to use fairly simple things to illustrate my point. So a related thing, if you've got an array of numbers and you want to find the biggest number, this is another challenge that I set them. They'll normally come up with something like this to start with. They'll use a for loop, get the first value to start with, go over each one and just say if the current value is bigger, just keep track of that. And then at the end of it, you know what the biggest number is. Seems nice and simple. I then teach them about array iterator methods, and so they use reduce instead. If you're trying to get an array down to a single value, you should use reduce. It's a nice functional way of doing things. Your code's much tidier. And they'll write something like this normally. And then I point out what you've actually got here is a function that takes two values, and if the second value is bigger than the first value, you return that. Otherwise, you return the first value. So you have here a function that takes two numbers and gives you back the biggest of those two numbers. So what you have here is the max function. So using a bit of functional programming, if we've already got the max function, we can just reduce it down to this single line of code here. And it does exactly the same thing as that 6 or 7 line for loop before. And it sort of almost reads as what it's going to give you. You're taking some values and you're getting the maximum value out of them. So this seemingly not very useful function, actually you can use it all over the place. And that's true of all sorts of functions. So another use case for this sort of stuff is Redux reducers. If you've not used Redux much, then the basic idea is that you get past the current state of the application and an action. Depending on what the action is, you then do stuff to state, just to change some value inside it. This is from the ping pong scoring app that we create. If the player 1 action is fired, then we want to just add 1 to player 1's score and then give that back. If the player 2 action, then we want to add player 1 to player 2 and then return that updated state. So this works nice, and that's normally what people come up with. I then, as the next challenge, ask them, okay, now you need to keep track of who's serving. So every time someone scores, you're going to have to work out if the server's changed or not. So every 5 serves, the server changes. And what most people end up writing is something like this. So they're going to update their player 1 function because it has to run when the player 1 or the player 2 action fires. So they need to get, if the player 1 is serving, they then get the score. They need to make sure they've got the latest score, so they add 1 to the player 1 score. They then work out if the server does need to change. And then if the server is changing, they flip whether player 1 serving the value of that. Otherwise, they just keep it as it is, and they update the player 1 score at the same time. And that will work. That's fine. I mean, a bit of a problem is you're going to have to repeat a lot of the same logic for player 2. It's going to be largely the same, but it works, and that's fine. But I would say, if it works, don't touch it. If you've got a function that works, it does something well, leave it alone. Use function composition instead. And you can do that by doing something like this. So we keep the player 1 and the player 2 functions exactly as they are. They just add 1 to the relevant player's score. To work out the server, we take the state again. We get the total of the 2 players' scores, see if they're divisible by 5. If they're not, we just keep the same state. The server hasn't changed. If they are divisible by 5, then we just change the player 1 serving. And then to get that to work, we just use function composition. So player 1 function gets called and we pass it the state. That then returns the state, which then gets passed into server, which then has the updated scores, and then updates the state if necessary. And then what you get back from that is the fully updated state that's got the server stuff and the player one stuff. The nice thing is we've not had to change the functions that work. We've got nice, simple functions that we're composing together. And the nice thing about that is it scales really well. You now want to, the next challenge, you now need to know if someone's won or not. So again, we're going to have to update something in the state to keep track of that. Most people's initial reaction, go back in and update the serving one or the player one or the player two one. But again, we can use function composition. So we have one that just takes the state again. If it's over 21, then we can say player one has won. If not, then we say if player two is over 21, they've won. Otherwise, nobody's won. And then again, we just wrap the whole thing here. So we get the state and then player one. That's going to update the score. We then pass the state immediately to the server function, which updates the server if necessary. And then we pass that to the winner, which again updates the winner if necessary. And all of our functions are nice and simple. So how can you sort of get towards code like this? So, I mean, these aren't hard and fast rules. They're just sort of, if you do these things, you'll probably find it a bit easier. So the first one is to write pure functions. So that means functions that if you give them the same arguments, you get back the same results, and they don't change anything else. If you write largely pure functions, you're going to find function composition much easier, because you can reuse those functions anywhere you like. The other thing is, if you treat everything as an expression, so in Haskell, the language that I mostly write in now, you don't have statements. Everything is an expression. Everything equates to a value. And if you think that way, you don't use if statements or anything like that. It forces you to write much more composable code, because you will end up writing lots of much smaller functions. And then you'll discover that you can then reuse those functions in lots of different places. I'd say here, unless it's DOM, you can't really do this with DOM, because DOM is very much just property-based and they don't return values. So if you're doing DOM stuff, you'll want to use some sort of library to do that. The function's purpose shouldn't contain the word and. So if I say, what does this function do? And you say, well, it does this and it does that. You've just there got two functions that you should compose together, rather than having one function. Split up the two different things, and now you've probably got code that's going to be much easier to make changes to later on. When you're doing this, you're going to end up with way more functions than you probably had before. So name functions or methods if you're doing object-oriented programming. Name them sensibly. If you don't name them sensibly, it's going to be very hard to do anything. Put them in sensibly named modules, give the functions sensible names. That can be hard. Naming is difficult, but do try and name them sensibly. And the final thing is just avoid anonymous functions. So when you're using anonymous functions at the moment, think about pulling it out into a variable, give it a name, and you might discover that you've actually already got a function that does that, like that max function. You might write the reduced version where you've got biggest and current, and then just realize actually that's a function that I've already got. So if you don't use anonymous functions, which is not always possible, but is generally possible 90% of the time, pull them out, give them a sensible name, and you'll probably discover that, again, you get much more composable code. So I do have some slides about the sort of technical aspect of function composition, but I've been talking for 30 minutes, so I'm not going to cover that. So it's just about sort of the more mathematical side of it. I don't think anyone really wants to be doing this at 7 o'clock in the evening. If you would like to go through that stuff, there is the slides are online. Small Hadron Collider / function composition. You can talk to me in the break if you want to talk more about that stuff. And if anyone has any questions now, then I can answer those. Anyone? Ollie?
So you got to a level at one point where you had sort of 3 functions in your composition there. When is too many?
Well, that's the nice thing about composition. You can break it up into smaller parts. So I'm not getting onto the technical thing. So the technical thing I wanted to show you is you can have this function here, compose, which looks like madness on stilts. If you can work out what that does, then well done. It's a crazy thing, but very nice. And what it lets you do is basically, once you've got that in your code base, this is always like the first line in my JavaScript code bases. I often put it as underscore because it's something that I use so much. You can then take any old functions and then you can compose them together. So you can say weird, because this is a bit of a weird function to be honest. Weird equals the composition of the max function followed by the times 3 function followed by the square function. And now you have a function that when you pass it 2 numbers, first it gets the max of those 2 numbers, then it times that number by 3, and then it squares that number. And what you'll get back is the result of those 3 operations. So the first thing in the composition can take as many arguments as you like. All the others just take the return value of the previous one. And it's kind of backwards. So it does this one first, and then that one, and then that one. Once you've got a compose function like that, and as I say, I generally have it as like underscore, you can then, so Redux, if you're doing stuff with Redux, that's based on Elm, and Elm was based on Haskell, so unsurprisingly, composition works really well with Redux, because Haskell is nothing but composition, basically. You can write something like this. You can say compose winner server player 1, and then you can just call that P1 function down here, which keeps that a bit shorter. But you'll notice here, we're composing winner and server both times. And so we could actually pull that out into a function that just does those 2 things and then compose that function with the player 1 and player 2 functions. And you might discover that this is actually then usable elsewhere, and you almost certainly will. The nice thing about function composition is the second you start doing it, you will find your functions. Oh, actually, I can use this here. Oh, I can use this here. And you'll suddenly just discover that things that you previously thought, that's not very useful, but I'll do it anyway, actually you end up using all over the place. So, I mean, as a Haskell developer now, like, literally everything I write is composition now. So this is an example of some of the Taskell code base. Like, this is probably the bit of Taskell that does all of the work. This is basically saying, when they click on the new key, store it, create a new item, and then start editing it. Like, it's all just the dot in Haskell is composition. So all of the behavior of my app is written basically in a single file that's just composing lots of individual functions together when a key is pressed, effectively. So, I mean, you know, you can never, if they're sensibly named, you can almost read it as what it is, which is really nice. So you can never have too much function composition. There may be performance reasons for not doing function composition. If you're writing a game and it needs to run at 60 frames per second, maybe don't use this stuff quite so much, because it can lead to garbage collection and stuff like that. But for sort of regular apps, which is what most people are writing most of the time, you can use it as much as you like. It's not going to give you any performance bottlenecks that are worth worrying about. Any other questions?
Are there any libraries that you'd recommend for nice kind of base functions that can be composed well together?
Yeah, so Ramda, which is the one that when I gave a talk 3 years ago was also the library that I recommended at the time. Ramda, it has the compose function built in. Actually, quite a lot of those sort of libraries, you know, things like underscore and Lodash and all of that sort of stuff, they often have a compose function built in. They often have compose function, but they also include your base functions like max and add and stuff like that. So if you've got one of those libraries, you can save yourself a huge amount of time, because they've worked out what a lot of the functions that you will use all the time are, and just put it in one place with documentation. So yeah, Ramda.js is the one to use probably. Anyone else? No?